Hello, and thank you for watching. Today I will present our work, V.I.P, Iterative Online Preference Distillation for Efficient Video Diffusion Models. Our goal is to make large video diffusion models lightweight and efficient without sacrificing quality. Let's start with the motivation. Conventional distillation methods, such as supervised fine-tuning, rely on fully imitating the teacher's outputs is suboptimal in pruning-based distillation. Pruned models have significantly lower representational capacity than full models. As a result, when trained with standard fine-tuning, they often produce over-smooth distributions and lose important details. Interestingly, we also found that pruned models can sometimes outperform the full model in certain aspects, for example, motion dynamics, because pruning removes redundant components. Therefore, naively mimicking the teacher's outputs can actually degrade the aspects where the pruned model originally performed better. To address this problem, we replace standard distillation with preference learning, inspired by direct preference optimization, or DPO. In this setup, we define the teacher's output as the winning sample, and the student's output as the losing sample for the specific target property where the student underperforms. Through this contrastive learning, the student learns to improve only in the areas it's weak, rather than blindly mimicking the teacher. This allows the student to allocate its limited capacity to the most essential aspects of generation. However, DPO alone often over-optimizes, so we introduce SFT regularization to stabilize training. Combining the two gives us our eDPO, regularized diffusion preference optimization. Finally, we integrate this into an iterative online learning framework, which enables self-reflection and effective recovery of the pruned model at each stage. The V.I.P framework operates in three main steps. First, automatic pruning. We prune blocks by ranking their evaluation scores. Second, data generation. We construct winning and losing pairs by generating prompts and videos from both full and pruned models for specific target properties. Third, distillation with our eDPO. We iteratively train the pruned model to recover degraded dimensions using our proposed loss. Importantly, this process is iterative and online, meaning at each stage, the student is updated, reevaluated, and pruned again. This allows gradual adaptation and self-reflection instead of abrupt one-shot pruning and distillation. Now, let's look at the results. We applied V.I.P to two state-of-the-art video diffusion models, VideoCrafter 2 and AnimateDiff. In the top table, you can see the performance of V.I.P. Even with 36% and 67% parameter reduction, the pruned models match or even surpass the performance of the full models. The second table compares our method with SFT-based distillation. Across both VideoScore and VBench metrics, ReDPO consistently outperforms SFT in nearly all categories, improving text alignment, temporal consistency, and overall visual quality. We also conducted user studies, and participants consistently preferred the videos generated by V.P. Visually, this difference is clear. Only the V.I.P trained model correctly generates the intended concepts. For example, producing a security guard in the prompt, or maintaining the spaceship structure and color consistency, while others generate blurry or colorless, inconsistent frames. Our ablation studies further validate the effectiveness of V.I.P. As shown in top table, when we remove the SFT regularization, the model becomes unstable and over-optimizes, leading to noticeable performance degradation. Similarly, using an offline setting, that is, one-shot pruning and distillation, significantly reduces performance. These results highlight that iterative online training plays a key role. It allows the model to reflect on its own updated outputs and progressively recover the capabilities lost from pruning. We also tested the robustness of V.P across multiple reward models. As shown in the second table, the results show that our method is not biased toward a specific reward model, and that using stronger or improved reward models can further enhance our distillation performance. These are our key findings. Method that naively mimic the teacher, SFT, is insufficient for distillation in pruned models. Iterative, online training that enables self-reflection and progressive recovery is crucial. Stronger reward models lead to improved performance, highlighting its potential for further advancements. Thank you for watching, and please visit our project page for demo videos and more details.